there's two main portions of the Communicator architecture that we're concerned with, and they align with the two basic places here, so the server and the client. So in our case, the client is the user that is going to be viewing the model, and the server is, of course, the machine that is hosting the data that it's going to send to the client. On the server, we have a number of components that we touched on in the previous module. So Hoop Server is the overall bucket that contains our converter and the stream cache application. So the converter is the front line of getting data into the system. You send your raw CAD data, whether it's JT file, NX, STEP, STL, into Hoop's converter, which is a native application built on Exchange and HPS, and also our SC authoring library, which we're going to talk about a little bit later. So the CAD file goes into converter, and what we're going to do, we're going to load that file, we're going to extract out all of the relevant data that we need. So with this data that we're extracting out includes BREP, the tessellated data. We're going to use Exchange to tessellate that data to basically send down the client for rendering. But also all of the model tree, so that hierarchy structure, and the properties of the tree. So for example, properties are things like in the BIM world, you have like IFC door or window. We can also calculate things like center of gravity and like the volume. So all that data is extracted using Exchange, and what comes out of that is a stream cache model. And the stream cache model has two parts. One is the assembly tree, which is all of the non-graphical data that we just extracted from Exchange. And that goes into this model alongside of the optimized mesh data. So now when we talk about optimized mesh data, what that's going to be is all that triangle data. We run some optimizations on it, like remove duplicates, things of that nature. And that's going to live in this file along with that assembly tree. Now, from this file, what we're going to do is we have an application called the Stream Cache Server, which I don't have to see there, but that can read this stream cache model, and it reads it in a way where it's smart about the way that it loads the data. So the system's optimized for building very large models, or viewing very large models, but we're not going to load all of this data at the start. We're only going to load some of it, what the viewer can see. So that's where the client comes in. So in the client, we have this stream cache client, which is a JavaScript class. It's a single file that contains all of the JavaScript you need for the viewer. Has public API, which we're going to talk about in a little bit, and it will communicate with this stream cache server via WebSockets. So you can see the WebSocket line here. So WebSocket connection is created between the server and the client. Now, the client is going to send data down the pipe to the server to say where the camera is. And the server will respond in kind with the relevant data that the client can see. And the server will seek through this file and grab the mesh data and the assembly tree data for that particular view. And as the client moves the camera, data will go back and forth over this pipe to keep the data flowing in what the viewer can see. So we'll dive a little bit deeper down into the two phases, or two portions. So on the server part consists of, we talked about the converter, but it also has the streaming server. Now, in order to facilitate viewing multiple models at a time, right, you can imagine, so for each client there's like a JavaScript class on the client, and then there's that stream cache server on the server. They create that connection via socket, send that data each way. But we need to have multiple clients being able to be served by the same machine. And each client can have its own state. They're each looking at different parts. So each client that views a model has to have a supporting process on the back end. And the way we deal with this is the Hoop server application. Now the Hoop server application is sort of a manager for all of these little streaming sessions. And the way you communicate with this is we have this concept of a service broker. And the service broker is exactly what it sounds like. It's a process that's running, and you can ask it for a service. And in our case, these services are things like client-side renderers. And the CSR is what we call the process that supports a client rendering. We also have what's called a server-side renderer, and that will do the rendering on that actual server and just send down images instead of data. And the service broker is your gateway to requesting these processes. So you'll make a REST request to our service broker and say, hey, I need a service that can support a client rendering, and it will return back to you data and how you would create one or communicate with one of those. The process manager is a sort of umbrella that will monitor each of these services that you create. So for every client renderer or server renderer you create, the process manager will make sure that it hasn't crashed. It will also monitor its health, like if there's some problem, if it's slow for whatever reason, it can observe that, and you can query the process manager to kind of see all your processes. And these viewer processes are what we were just talking about. These are the things that are actually spawned on the back end and are communicating with that client. In terms of platforms, we're only run on 64-bit. That's pretty much standard nowadays for server stuff. We're running on Windows Vista, SP2 and newer, and Windows Server 2008 and 12. Those are the Windows platforms. Then for Linux, we support CentOS 5.9 and newer, and Ubuntu 12 and newer. We also run on Amazon Linux and some other Red Hat variants. So we haven't really had any problems in terms of distributions for Linux that we haven't been able to get running. So those are the most popular ones.